Actually, in today's lecture, we are going to learn how to find the Laplace transform of a given integral. Let me first of all remind you that if you need to find Laplace of the function f of t, if you remember using the definition of Laplace transform integral from 0 to infinity exponential st times my function f of t dt. Now, if you remember, after that we studied Laplace transform of a derivative of my function. So it's given to be, if you remember, s times f capital minus f small of 0. Now, in today's lecture, we are going to learn how to find the Laplace transform of the integral of my function. Not only my function, let me call here tau and tau, from 0 to maybe say, let me say t. So in today's lecture, we are going to find the Laplace transform of a specific integral for the given function, not its derivative, but its integral. Here are the objectives, which we are going to cover today. And here my cheat sheet, not all the rules, which we studied in the previous lectures, starting from the Laplace transform, the definition. I summarized here some of them. Here the general definition given by integral, and here two rules for the derivatives. Here the shifting theorem for the x-axis and its inverse here. And here the shifting theorem for the t-axis with its inverse here. Those are the rules. And here the Laplace transform of the t times the function which is given to be the derivative. And here for any power for t to the power n. So notice here, for this and this and this, we studied a product between two functions. Here exponential, here the unit step, and here it is t. But we didn't study how to find Laplace of f times g in general. No, only for three different cases, the t or t squared or t to the power n, and the exponential a to the t, and the unit step t minus a. Only those three. Also, we studied the inverse of this. If you take the inverse for both sides, so you can tell me that inverse Laplace of the derivative of Laplace of f small of t is given to be negative t times f of t. If you remember this rule, it's the inverse of this. The inverse of this. Also, instead of Laplace of f of t, you can say it is f capital of s. Don't forget that f of s, it's Laplace of f small f of t. And you can say that f small of t, it is the inverse of f capital. Don't forget those notations, okay? Those we studied and used them to solve many problems. Today, we are going to study how to find the Laplace transform of an integral. First of all, also let me remind you the definition of the convolution between two functions. If you have f and g piecewise continuous functions, you need to find their convolution. You need only to take the integral to t, f of tau, the first function with tau, g of t minus tau. You have shifting here for the second function. Don't forget that f of s, it is Laplace f of t, is given by this formula tau tau, okay? Or g here, beta beta. So don't care about those letters, okay? Do you want to say anything, David? Now
No,
the
sir,
convolution.
it was a mistake.
Yeah, no problem. The convolution theorem said if you have this convolution and you need to find its Laplace transform. So my aim now is to find Laplace of the convolution between those two functions. We can prove easily is given by this formula. So it's Laplace of the first times Laplace of the second. And Laplace of the first is f capital. Laplace of the second, it's j capital. So the rule today, which is very important rule, Laplace of the convolution. This one is convolution, not general product, not a standard product. It's a convolution. It's given by Laplace of the first and Laplace of the second. But no one can say that Laplace f times g is given to be Laplace of f times Laplace of g. No, this one is very big mistake. Very big mistake. Only if it is convolution. I can say it is Laplace of the first and Laplace of the second. How to prove this theorem? Actually, to prove the theorem, you need to use the probabilities of double integral. The most important one, the interchange between two integrals. So if you have two integrals, double integral, you have to replace them. The first will be second and the second will be first, depending on the probabilities of the double integral to prove this theorem. Actually, I proved for maybe for one semester, and I have a short video for this proof to explain the proof. If you need, I can send you the proof, my video, and also you can read the proof from the textbook. But for me, isn't important. Okay. So now, starting from now, if you need to find Laplace of a convolution between two functions, you have to find Laplace of the first and Laplace of the second. Don't forget that fg is given by this formula. So starting from now, if you asked me to find Laplace of this integral, notice ft from 0 to t, f tau, g of t minus tau, d tau, this it is the same of this convolution. So we'll take Laplace of f and Laplace of g. Let me give you one example and you will find it's very easy. Here the theorem, here the definition of the Laplace of the convolution, and here the theorem. Let us together try to find the Laplace transform of those two functions. So now here, let me start. I'm asking you now to find Laplace. Let me use the PowerPoint pen. It's better, I think. So I need now to find Laplace. You need to find Laplace of this function. Okay, your question, find the Laplace of this integral. Yeah, what should I do? For me, I remember the rule which said Laplace, here let me write, Laplace of the integral from 0 to t, which is the convolution, f of tau, g of t minus tau, d tau is given to be Laplace of f times Laplace of g. So I have this rule. I'm going to use this rule. Yeah, how to do that? So for me, let me identify the f and g. Can anyone help to determine my f and g? Where is your f now? F of tau. Where is f of tau?
Tau squared.
Tau squared. So from this, you can tell me my f of t. So if your f of tau, it is tau squared. So f of t is what? Let me repeat. This one, it is f of tau. So f of t is what?
T squared.
T squared. Okay. Where is your g of t minus tau? This is my g of t minus tau. My question, I need g of t. Where is g of t?
5t.
Yes, so here, t and t, let me write. It is e to the power 5t. Any question about determining the f and g? Actually, if you can determine f and g, so you finish the problem. Let me use the rule. The rule says you need to find Laplace of your function f, which is t squared, times Laplace transform of your function g, which is e to the 5t. For me, I memorize those is given to be 2 over s to the power 3 times 1 over s minus 5. Finished. So I can find the Laplace transform. I can find the Laplace transform of an integral using the convolution rule, convolution theorem. Let me check the second one. This one is very easy. Here is the second one. Let me write the rule here. Here down. I'm going to write the rule down here, using maybe the blue. So the rule said Laplace of an integral from 0 to t f of t times g of t minus tau d tau is given to be Laplace of f of t times Laplace of g of t. Okay, and this one, it is the same of Laplace of f convolution g. I understand this. Now let us together try to check if I have the same integral. So now my aim is to find Laplace of this integral. Do I have the same rule here, or what do you think? What is the difficulties? What is the problem in my integral? Can I decide where is my f? Yes, speak.
I can't decide where is g of t minus tau.
You can or you can't?
I can't.
You can't. Yes, other students can. So now my aim, I need one to help to determine the f and the g. F of t and g of t. Can anyone decide? By the way, I have two different things to do now. Where is my f and where is my g?
We'll take it all as f and say that g equals 1.
Great, great, excellent. So Islam suggests, Professor, let me call all those are my f. So f of t is given to be t squared e to the 5t. I agree. Where is the g? G of t is only 1 here. I have times 1. So let me call my gt is given to be only 1. So the rule say Laplace of your f, which is t squared e to the 5t, times Laplace of g, which is given to be 1. How to find Laplace of t squared times exponential?
I'm shifting.
You can use the shifting, and you can use the differentiation rule. Okay, so which one do you want to use now? You are free, by the way. I'm going to write the rule down.
I think shifting is easy.
Yes, so I'm going to write the shifting rule down here. So you need me to use Laplace transform of e to the at times f of t, because I don't have my cheat sheet now, so I'm going to write the rules. Do you remember this one? It is given to be Laplace of f of t as it is as usual, but after finding the answer, please shift your s into s minus a. Okay, so where is your f now? Where is your f in this problem? In this one.
T squared.
T squared, this is f. So I'm going to apply this rule now. So equal Laplace of t squared, and I need to shift my s into s minus 5, because you multiply by e to the 5t, okay? And multiply, don't forget the Laplace of number 1. I forget. Laplace of number 1 is given to be what? Laplace of 1.
1 over s.
1 over s, great. Now Laplace of t squared, I remember Laplace of t squared is given to be 2 over s to the power 3, and I need to shift my s into s minus 5 times 1 over s. Shift please your s, so you have 2 over s minus 5 to the power 3 times 1 over s. It is s. We finished. This is the first method. Let me use second method now. Not the differentiation, no, not for this, from the beginning of my integral. So let me use another color now. Maybe I'm going to use the white one. So my aim now is now second method, Laplace of integral from 0 to t of tau squared e to the 5 tau. Now I'm going to use what Mera said, Professor. I can't find the gt minus tau. I can't decide that my f is tau squared. Yes, where is the shifting? So to do the shifting, I'm going to do my shift by hand. So integral from 0 to t, tau squared as it is, e to the 5. I'm going to shift now. tau minus t plus t. So I add and subtract t to see the shifting d. Ongoing. I need those two together because here the rule said that the shifting. So I need those together, and I'm going to multiply the 5 by them and the 5 by t. So I have here Laplace of, so equal Laplace of the integral from 0 to t, tau squared e to the 5 tau minus t e to the 5t d tau. Am I right here? For me, e to the 5 tau is a constant with respect to tau. So take it out of the integral. So you have Laplace here, I'm sorry, equal e to the 5t, leave it as it is, integral from 0 to t of tau squared. Notice the shifting need t minus tau. So you need to take the minus as a common factor. So 5 t minus tau d tau. Now I have, look, you have Laplace of a product between two functions. The first one exponential and the second one is this integral. The rule said if you have exponential, do the shifting. So it is Laplace of my integral from 0 to t, tau squared e to the negative 5t minus tau d tau. After finding the answer, I'm going to shift my s into s minus 5. This is the rule. Now, let us continue here. I'm sorry. I'm going to write here equal. How to find Laplace of this function? It's very easy for me, Professor. Only I need to determine my f of t and g of t. Where is my f of t? It's t squared. This is f of t. It's t squared. Where is my g? I'm going to apply this rule now. Where is my g? G of t. Can anyone help? Where is the g of t?
e to the negative 5t.
E to the negative 5t great Islam. So equal. Let us continue now. The rule said find Laplace of the first and Laplace of the second. So it is Laplace of t squared times Laplace of e to the negative 5t. And I need to shift all of them s into s minus 5 equal 2 over s to the power 3 times 1 over s plus 5. And I'm going to shift my s into s minus 5. Replace it now, please. So equal 2 divided s minus 5 all to the power 3 times 1 over s plus 5 and minus 5. You can cancel out this 5, this minus with this plus. So you have the same answer. Notice s minus 5 to the power 3, s minus 5 to the power 3, and 1 over s, 1 over s. Professor, the first method is easier. Great. If you can decide in the exam that this steps will save my time and it's easier for me, please do that. And by the way, in today's lecture, you can see that some problems can be solved using 3 rules or 4 rules, and you are free in the exam. Choose which one you find it's easier for you. Okay? Any question? Let me go and solve more problems now. Actually, now I'm going to study the inverse of this formula. The inverse of Laplace transform of the convolution rule. It's easy for you, I think, to take the inverse for both sides. So if you take the inverse here, inverse. So by the way, this one, it is Laplace of f convolution g. Am I right? With this integral. And this one, it is Laplace of f of t times Laplace of g of t. Am I right here? Now take the inverse, you will cancel out this L with this L inverse, and here you have Laplace inverse of this and this. So what I need you to understand, Laplace inverse of a product between two functions is given the convolution of their functions. So here you can say that Laplace inverse of f capital of s times g capital of s is given to be Laplace inverse of F capital of S, convolution, not a product, Laplace inverse of G capital of S. By the way, Laplace inverse of F capital is what? Laplace inverse of F capital is what?
F
F
small of
small,
t.
F small. So I didn't write anything here, the same, but the other notations. So I think if you can go easily from one notation to the other, so Laplace transform in this lecture will be easy for you. Okay? Did you understand the rule of inverse Laplace transform of the convolution? Now let us together try to find the inverse Laplace for this problem here in the coming slide. By the way, we did similar to this, if you remember, in our worksheet, last worksheet. Similar, very close to this one. We did very close to this one in the previous worksheet. Can anyone of you remember how to find the inverse of this depending on the rules in the previous lectures, not today lecture? Do you remember how we found this one?
Differentiation of sine.
Yes, this one, it is, yes, it is a differentiation of sine. You are right. So you can use it, but for evidence said in the previous lecture, Professor, I don't can catch the idea of differentiation easily. Maybe I'm not good in differentiation. Don't worry, you can solve the problem using today rule. It's very easy. Today rule, let me write the today rule here down. So I'm going to write the today rule down here using the maybe red here. Today rule said if you need to find Laplace inverse of a product between two functions f of s and gs, okay, the rule said it is f small convolution g, and I think all of you know the definition of the convolution between two functions, okay? But notice to solve this or to apply this rule, you have to know that if capital of s, it is sorry, it's better to write Laplace or no problem, Laplace of f capital, Laplace, I'm sorry, if capital of s, it is Laplace of f of t. And that mean nothing here. That mean f of t, it is Laplace inverse of f capital of s. You have to remember those rules, okay? Now let me check if I can use the rule here, the inverse of convolution, to find the inverse of my function. Let me start solving here using the yellow. So Laplace inverse of 2s over, it is s not 25, 2s over s squared plus 4 squared. So you can solve this problem using the differentiation rule, but for me, I'm going to solve it using my convolution rule today. The convolution rule need a product between two functions. What is the product now? Can you write your fraction as a product between two functions? What do you think? And take care, the product must be for two functions. Each one of them you can find its inverse easily. What do you think? No one of you can write this fraction as a product between
2 over s squared plus 4.
2 over s
Times
squared
s.
plus 4 times what?
Times inverse Laplace s over s squared plus 4.
Actually, I'm sorry to say that you can't say that it is Laplace inverse of the first times Laplace inverse of the second. You can't say, look to the rule. If you need to find Laplace inverse of a product, so it is the convolution between those two functions, not the product. So it is, let me write it here, Laplace inverse of f capital, convolution, not times, convolution of Laplace inverse of g. Okay, it isn't, I'm not sure if I should write it in another way, just 1 minute, because I saved it as a PDF, so you need to understand it. Just 1 minute, give me 1 minute, and let me use the red here, it's better, more. And please check, the other students check if what your colleague said now is right or wrong. So this one, it is here, it is F convolution G, which is equal to the Laplace inverse of F capital of S convolution Laplace inverse of G capital of S. Now, my question, this product is equal to my function or no? Check, please. The product of those two fractions give me my fraction?
Yes.
Yeah, great. So now let us together decide that this one, it's our F capital of S. And this one, it's our G capital of S. Could you please tell me your Ft, which is the Laplace inverse of your F capital of S? Can anyone of you remember?
Sine 2t.
Sine 2t, great, excellent. What about of this? Could you please tell me your GT?
Cosine
Sine 2t.
Cosine 2t, great, excellent. Let me apply the rule. Go back to the yellow and apply the rule of the inverse of a product between two functions. It's given to be, the rule said F convolution G, which is the convolution, I remember it is the, so let me write it is sine 2t convolution cosine 2t. The convolution is given by the formula integral from 0 to t sine 2 tau times cosine 2 t minus tau d tau. Am I right by this definition? Now, how to find this integral? By finding this integral, we finished solving the problem and we found the inverse Laplace. Who can help to find the inverse of this, or sorry, this integral? Integral of a product between two trigonometric functions. Do you remember?
We can take u equals cosine 2 t minus tau.
And then so I think we have some rules to integrate a product between two trigonometric functions, sine and cosine, if the power of sine is odd or if the power of cosine is even. So we have some rules. And also, by the way, if both of them of power 1, so you can convert this product into summation using this rule. Do you remember those rules? So you have sine times cosine. For me, I can't integrate this product, so I'm going to convert into a summation using this rule. So let me apply the rule. So equal integral from 0 to t half bracket sine of the summation between them, sine of the summation. Please add your angles. So 2 tau plus 2t minus 2 tau, it is only 2t. Plus, I'm going to apply the rule, sine of, now the subtraction, 2 tau minus 2t plus 2 tau, so it's 4 tau minus 2t. Am I right by this rule? Here, all of them d tau. Now I need some help to integrate these functions. The half is a constant. What about of the integral sine to t with respect to tau? Do you remember how to integrate the sine? Integral of sine to t, please, with respect to tau.
Sine 2t
constant.
tau.
Sine 2t tau. It's so sine 2t, it's a constant with respect to tau. So I can deal with it as a number 5. Integral of 5, it is 5 tau. Okay? So the integral, it is tau sine 2t plus, what about of this? With respect to tau, yes, it's a negative. I'm sorry. I need negative now because the integral of sine is a negative sign, and I need to divide by 1/4. So it's cosine 4 tau minus 2 It's 2, not tau, 2t. Don't forget your boundaries from 0 to t. Those are rules. Equal. Now let me plug in the number, the t first. I'm sorry. So here I have t sine 2t minus 1 over 4. Now you have cosine 4t minus 2t. It's cosine 2t, cosine 2t. Now minus, I'm going to plug in 0. So 0, it's 0. Minus and minus, it's a plus 1 over 4. Cosine 4 0 0 negative 2t, negative 2t.
دبر الهاف
What?
خلاص.
So equal the half outside. I have t sine 2t, sine 2t. Now note here, if you have minus inside cosine, and we know that our cosine function odd or even, the cosine odd or even?
Even.
Is even. So if you have minus inside the cosine function, so the minus will be what? How to deal with this minus? Do you remember? The even function will eat the minus. So I have only cosine 2t. So it's negative 1 over 4 cosine 2t plus 1 over 4 cosine 2t. Now you can cancel out this with this. So your answer, it's half t sine 2t. And if you use the differentiation rule, you will find it's the same answer. Maybe some students will say, Professor, I can finish this using the differentiation rule in 2 minutes, but now you solved it maybe using in 5 minutes. So it's better to use the differentiation. You are right. You are free. Do what you want in the exam. But some students will think 10 minutes to check that this function is the differentiation of what? So they will lose the time. So I can apply this immediately. Any question?
Doctor, why didn't we stop at sine 2t times cosine 2t?
Here, at the star, in this star.
Yes.
You said times. Unfortunately, this one, it isn't times at all. This one, it is a star. Is there any difference between sine 2t times cosine 2t and this star? Yes, this, it isn't a general, it isn't a standard product. It is given to be the convolution. The convolution. I'm not sure if you noticed from the beginning that this star, it isn't a product. Let me go back one slide. Just give me 1 minute. Go back here. Where is the convolution? Here the convolution rule. Notice the convolution rule here. This is the convolution rule, Mahmoud.
Okay.
It isn't at all a product between two functions. Starting from now, if you have a product, you must write f dot g, not star. If you have star, so it's a new operation. Okay?
Okay, doctor.
Great. Other students, do you have any question about our problem here? So you can't stop. Where is my problem here? You can't stop at sine star cosine, because this is a new formula. You need to continue and find the integral. Okay? Any question? Now, in a special case, if I need to find this integral, notice my aim now is to find the Laplace transform of only one integral without g. So I can consider my g to be 1. So if this is 1, so here don't forget that it is Laplace of f times Laplace of 1. Laplace of f, it is f capital. Laplace of 1, it is 1 over s. So you have f capital times 1 over s. So you have f of s divided of f of s. So starting, by the way, Islam suggests this rule before we study it. We solved the first problem in today, second problem actually in today's lecture using this rule. Integral of something without shifting. I can consider all of them as one function and apply this rule. So starting from now, Laplace of an integral, notice it's t, it's t. If it isn't t, don't do it. Don't use this rule. F of tau d tau equal f of s. What do I mean by f of s? It is Laplace of my function, the integrand function. This. Okay, did you get the idea of this problem? Now I need its inverse, the inverse of this rule. I'm not sure if I have it here. Just 1 minute. I need you to write your names, please. Write your names first, and let us study the inverse of this rule. All of you, please write your names and let us study. So here, our second rule, in a special case when my g is 1, is given to be Laplace integral from 0 to t of a specific f is given to be Laplace of f divided by s. I need its inverse. So take inverse here and take inverse here. So what I need to explain now, if you need to find the inverse of this fraction, so your aim to find the inverse of this fraction, so please write this integral. It's a rule. You have to write those rules and add them to your cheat sheet. Please, who didn't prepare the cheat sheet, you have to do starting from today. And please, who didn't start studying Laplace transform from the beginning. So my advice, if you find Laplace transform some difficulties to solve their problems, please go to the first lecture and do some revision of first lecture of Laplace transform, section number 7.1. Okay. By the way, from today lecture, one question in the final. From tomorrow lecture, one question in the final. From lecture of after tomorrow, also one question for the final exam. So those lectures are very, very important. Take care about of them. Now, let me explain more that if you have f of s divided s is given by this integral. It's similar to the Laplace of a product, but here now I have division. Okay, let me solve one problem of them and you will decide. Yes, I need this one. So I need you to find the inverse of this problem. Let me go to black slide here and together, let us discuss how to do this or how to find the inverse Laplace of this one, not only depending on today's lecture. So I need one to help how to find inverse Laplace of this fraction depending on the previous lectures. Who can help? Any idea? How to find inverse of this function?
Partial fractions.
Partial fractions. So a over s plus b over s squared plus c over s plus 2. And you can find easily a, b, c. Yeah. And I think this problem will take maybe from those who practice a lot, 2 minutes using partial fraction. But I'm sorry, maybe I'm going to solve it now in 8 minutes. Why do you want, professor, to lose your time and use another method, not partial fraction? We all are familiar with partial fraction. Actually, sometimes you have one problem which you can't use it using partial fraction, or using today's rule will save 3 minutes. My aim now is to explain how to use today's rule. Okay? Actually, this problem also is difficult. So I'm going to solve it in 2 steps. First, I'm going to find Laplace inverse, not of my function, no, of this function, s plus 2. Then I'm going to second, I'm going to find Laplace inverse of my problem. Professor, so if you give us this problem in our exam, should we write first and second? No. No, you can do partial fraction, or you can do today method, today rules, without writing first and second. But for me, because I need to explain in detail, so I should do that. Yes, Professor. Yes, I think also the first one. So I'm going to solve first now. Find inverse. How to find inverse of the first one? It's very easy to use partial fraction. It's very easy. But for me, I'm not going to use partial fraction. By the way, also, I can write it as a product between two functions. So I can write this one as 1 over s times 1 over s plus 2. This comes from number 1. This comes from e to the negative 2t. Take the convolution between then one convolution e to the negative 2t. You can do that. You can do that. For me, I'm not going to do that. I need to use the new rule. So notice that our problem can be solved using 3 different methods. Which one is better, Professor, in the exam? No, not me who will decide. The students will decide. Okay? So here, let me say again that you can solve this one using partial fraction. You can solve it as 1 over s squared times 1 over s plus 2. This is your F capital, and this is your G capital. From this, it is it is t, the inverse, and this is e to the negative 2t. Apply the convolution between them and take the integral. You can do that. Those two methods. The third one, f of s divided s. I'm going to use this now. Why? Because I need to explain how to use it. Okay, now my aim, let me here down write the rule which I need to use using maybe the red, maybe, or I can write it up here. So the rule which I'm going to use now, I'm sorry, just 1 minute. I'm going to use the rule Laplace of sorry, f of s divided by s is given to be integral from 0 to t f of t dt. I'm sorry, f of tau d tau. What do I mean by f of t? It is the Laplace inverse of f capital of s. Don't forget those rules. Okay, and let us now together try to write our function in first using this rule. How to write your function such that I can write this rule? It's very easy, Professor. I can take the s down. So it is 1 over s plus 2 all divided by s. Can I do that? What do you think? Can I do that? Can anyone explain why this fraction is the same like this? Speak, please. David, why this fraction is like this fraction?
عشان عادي نرجعه ونضرب الدينومينيتور في الدينومينيتور.
Yeah, so I will flip this the denominator, so it will be 1 over s multiply it, so it will be the same. Now this
دكتور
is
هو نانسي هو shouldn't the Laplace f s over s shouldn't it be Laplace inverse?
Could you please repeat?
The rule in the green on the right.
Here. Yes. Here.
Shouldn't it be Laplace?
Yes, I missed this one. Yes, you are right. Always for s you need inverse. All right. So now the rule, now this is my f capital of s. This is my f capital. Can anyone of you tell me the f small? The f small? If your f capital is 1 over s plus 2. Your table, please. Your table.
e to the power negative 2t.
e to the power negative 2t, you are right. So now I'm going to apply this integral rule from 0 to t, e to the negative 2 tau d tau. This is the rule, which equal, let me continue here. I can integrate this function easily. It's negative 1 over 2 e to the negative 2 tau from 0 to t. which is given, plug in please t. So you have negative half bracket e to the negative 2t minus plug in the 0 e to the 0, which is 1. So I can understand now inverse of this fraction is this function. Now let us do this. How to write this one? How to? I need to solve this one using our rule, the green rule. Can I do that? The green rule need your denominator to be s. So can I do the following? Look now, please. 1 over s plus 2 all divided s. Can I do that? What do you think? Is it clear? This
Yes.
now this is my f capital of s. Where is your f small? Where is your f small? Where is your f small? Can anyone tell me if this is your f capital? Where is f small?
That's what we got in the first step.
Yes, it is here. This is the f capital here, the blue one. So this, it is my f small ft. This is my f small of t for this function. Okay, so I simplified this problem. So I do first and second, but maybe one of you can do this in one step, not first and second. So let me go back to the yellow and apply the integral formula. It is integral from 0 to t of my f small. So it's negative half e to the negative 2 tau minus 1 d tau. This is the rule. Negative half is a constant. How to integrate those? Now for me to integrate those, e to the negative 2 tau, it's also negative half e to the negative 2 tau minus tau. Don't forget your to t, which is negative half outside. Plug in please the t first. So negative half e to the negative 2t minus t minus, it is a plus because I have here minus, so it's a plus half because e to the 0 is 1 minus 0, or it is plus 0, no, plus 0. So the final answer, it's negative half e to the negative 2t minus t plus half. If you try to use partial fraction, you will get the same answer. You are free. If you use the product between 1 over s squared and 1 over s plus 2, you will get the same answer. Is it clear? Great. Now, actually, the most important aim of today's lecture is to solve integral differential equation. Professor, what do you mean by integral differential equation? Let me explain. Do you remember that in the first lecture, we said differential equation, that means you have an equation with the derivative of your function. Also, let me say now, integral equation, that means you have an equation with an integral for your function. What do I mean by integral differential equation? That means I have an equation with the derivative of my function, my unknown function, and its integral. Look to the equation number 50. You have here first the differentiation of the y. So here I have the differentiation of y, and here I have the integration of y. So I'm going to call it differential and integral. So let me call it integral differential equation. And in some books, you will find its name of Volterra integral differential equation. Okay, so our aim is to solve those integral differential equations or integral equations. By the way, 100% you will find in your final one problem similar to those, And 90% you will find one problem similar to the previous ones, which I solved in today's lecture. So from today's lecture, maybe you will find 2 problems in your final. So it's very important. Let me now solve the first equation, number 50. It's an integral differential equation. How to solve, Professor, integral differential equations? Similar to what we did for differential equation using Laplace transform. And by the way, no one of you know any rule or any method to solve integral differential equation and this one, Laplace transform. For other courses, maybe the students can solve integral equation using another methods. But for our course, only Laplace transform. Let me use Laplace transform now to solve this integral differential equation by using or following the same steps. Here the solution. First step is to take Laplace transform for all terms of my equation. So it is Laplace of y prime plus 6 Laplace of y plus 9 Laplace of this integral. Don't worry, we are going to find the rules for all of them. And for me, it's very easy because I have my cheat sheet in my mind, and you have to prepare your cheat sheet equal Laplace of number 1. My cheat sheet state that Laplace of y prime is given to be sy capital minus y small of 0 plus 6 Laplace of y small. I don't have in my cheat sheet Laplace of y small. Can anyone help?
Y capital.
Y capital, great. Plus 9 Laplace of an integral. Do we have a rule to find Laplace of an integral? Let me go back. Laplace of an integral. Here, Laplace of an integral. Notice the rule, Laplace of an integral. This one, it's given by f of s. No, Professor, what do you mean by f of s? This one. What do you mean by f of s? This one. It's Laplace of my function. Yes, it's Laplace of your function divided of s. Okay, let me write it. Did you get the idea here? Is it clear, this formula? I'm going to use it now. So now it is Laplace of my function. Where is my pen? I'm sorry. Yeah, I'm going to cancel it out after the lecture. Here I have Laplace of integral. The rule of Laplace of integral, the denominator s, and the numerator, it is Laplace of my function. Equal Laplace of 1, I memorize it to be 1 over s. It's clear for me. Now only I need to simplify this. This is 0. So I can write here now s y capital plus 6 y capital plus 9. Laplace of y small, it is y capital as you told me, divided s equal 1 over s. Now I'm going to take y capital as a common factor. Equal 1 over s, a common factor. So I have s plus 6 plus 9 over s. For me, I'm going to find the common denominator for those. So I'm going to multiply by s here, maybe. Here the denominator 1, and here the denominator 1, multiply here by s, and here by s, up and down, up and down, up and down. So what do I have now? I have the following. Let me write in details. The yellow, please. So I have s squared plus 6s plus 9 all divided by s y capital equal 1 over s. Don't forget that your second step is to eliminate y capital. How to find y capital?
We can cancel 1 over s with 1 over s.
Yes, you are right. Or multiply both side by s to cancel it out, then divide by this bracket. Or cross product, take this up and take this down. You are free. Okay, so for me now, I'm going to write the following. S divided by s times s squared plus 6s plus 9. Cancel out s with s. And now third step, do you remember third step is to take inverse Laplace of y capital is given to be inverse Laplace of your fraction, which is not easy for me. How to help me now to find the inverse of this fraction? How to find the inverse of this fraction?
We can factorize the denominator.
Yes, factorize the denominator. Could you please help? It's very easy, I think.
S plus 3 squared.
S plus 3 squared, great. How to find the inverse of this? How to find it? Yes. 1 over S plus 3 squared. How to find its inverse? What do you think? I can do that using two different methods. Let me write the rules up here using another color. Space. I didn't have space, so I'm going to write in the same style here. Who can guess which rule can help now? What do you think? First one, which is the easiest one, I think. And by the way, three different methods can solve this problem. You can say it is Laplace inverse of 1 over S plus 3 times 1 over S plus 3. Am I right here? And this is given to be the convolution of those. Which this one comes from where? And this one comes from where? This comes from where?
e power negative 3t.
E to the power negative 3t. And this one comes from where? The same. So you need to convolution them. E to the negative 3t, convolution, e to the negative 3t, which is given to be integral from 0 to t, e to the negative 3 tau times e to the negative 3t minus tau dt. D tau, which is given to be here negative 3t, plus 3 tau. Cancel out with this. So you have only integral from 0 to t, e to the negative 3t, t tau, which is given to be, yes, can anyone help? Negative 1 over 3, am I right? No, negative 1 over 3. What do you think?
It's tau e power negative 3t.
Yeah, because this one, it's a constant with respect to tau. Your integration with respect to t. So it is e to the negative 3t times tau. From 0 to tau, from 0 to t, plug in, please. So it is t e to the negative 3t minus 0. This is your yt. This is your yt. This is the solution of your integral equation. Professor, could you please explain other methods? I'm not going to write them to find inverse of this. Can anyone help?
The translation method?
Yes, the translation method, you are right. So I remember the rule. Let me write here the rule. The red one, I'm not going to save the red one, okay? Only to write other methods. I remember Laplace transform of inverse of S minus A, as here, is given to be e to the at times Laplace times f of t, times f of t. So I have my A now, my A, it's negative 3. So it is e to the negative 3t. And here I have squared of something. Do you remember it is t? So it is t. So you can apply without any integration and anything at all. Okay? The second method maybe the, I forget the third method. So first one I wrote as a product. Second method I wrote it as a shifting. Actually, I forget the third method.
Derivative?
The derivative. Yes, I'm so sorry. The derivative. This one can be considered as a derivative of what? 1 over s plus 3, but you need negative. Okay. So don't worry, because in the exam, give yourself only maybe 30 seconds and decide, I need to use this one, this method. Okay. Now let me solve another problem about the integral differential equations, and remind me to speak about the final by the end of this lecture. I have this one. Professor, no derivative here. Don't worry. Don't worry, no derivative, don't worry. But how to solve this integral equation? I'm going to apply Laplace transform for all terms of my differential, my integral equation. So here is the solution. Let me start from here. Here is the solution. I'm going to take Laplace of f small of t, you know, yes, no problem if I wrote no, equal Laplace of this product t e to the t plus Laplace of this integral from 0 to t tau f of t minus tau d tau equal Laplace of f of t, as you told me it is f capital of s, equal Laplace of t times e to the t. Let me write the rules down here for those who didn't study, didn't start preparing for the final. Don't forget that Laplace of t times f of t is given to be negative first derivative with respect to s to your Laplace f of t. Okay, this is my rule. What about, before I continue solving my problem, what about of Laplace of this integral? What do you think about of Laplace of this integral?
Will be Laplace of the first times Laplace of the
Laplace of the second, yes, great. Could you please tell me your first function is what?
t.
T, you are right. And second function?
F of t.
F of t, great, great, excellent. So I'm going to use today rule. So let me go back to the yellow. 1 minute. So equal, let me apply the rule. It's negative, the derivative, first derivative of Laplace of e to the t. What do you think? By the way, in the previous section, one student said, Professor, can I use the shifting instead of the differentiation? And he said, Professor, because the shifting is easier than the differentiation. So here also I have the rule, Laplace transform of e to the at times f of t. Similar to my problem now, I have a product between t and e to the t is given to be, do you remember here the rule? It is Laplace of f of t. And you need to shift your s into s minus a. Those rules here. But we start using this rule, no problem, I can do that, don't worry. Plus, as you told me, you need to write the Laplace of the first times the Laplace of the second. From where you get this rule, Professor? How to write the Laplace of an integral to be Laplace of the first times of Laplace of the second? To the rule. It's the Laplace of the convolution. Let us continue. That will give me, I'm going to write here, if capital equal, first derivative. I'm sorry to use this one, but because I'm a student now, in the exam, don't worry if you use this rule or this. Laplace of e to the t is given 1 over s minus 1 if I remember. Plus Laplace of t is given to be 1 over s times Laplace of f small, it's given to be f capital. That will give me, I'm going to write here, f capital equal. First derivative, so what do you think about the first derivative? It will be negative, and I have negative, so it is 1 over s minus 1 all squared. Plus 1 over s, f capital. So I'm going to move them all here. So f capital minus 1 over s, f capital, equal 1 over s minus 1 all squared. Take f capital common factor. The coefficient of f capital, it will be 1 over negative 1 over s equal 1 over s minus 1 all squared. Now here makes a common denominator. If I try to make common denominator, so I have s minus 1 divided s. F capital equal 1 over s minus 1 squared, multiply up and divide down. Am I right here, or did any mistake? I think there is something wrong. I think there is something wrong here. Who can find the mistake and deserve one chocolate? You can go step by step and check where is the mistake. I did something wrong here.
دكتور مش هي المفروض 1 over s squared؟
Great, Mahmoud. It's 1 over s squared here. The Laplace of t Laplace of t, it must be 1 over s squared, not 1 over s. So here s squared, great Mahmoud. And here 1 over s squared. So you need to multiply. So here s squared and here s squared. Now cross product to get the second step, which is f capital. Here the first step to take all Laplace transform f capital equal s squared divided by s minus 1 squared times s minus 1, but the squared for s. Third step is to take inverse Laplace for f capital, which is your f small, to be the inverse Laplace of this fraction. Maybe I'm not going to do this, and you will. We can discuss, but I need you to do that and send me your solution in WhatsApp. How to find the inverse of this fraction? So here it's given f small of t, which is the solution of my integral equation, is given to be by this formula. How to find the inverse of this?
Fraction. Can we use partial fractions?
Yes, I can do partial fraction. But before using partial fraction, we should factorize the denominator. Can we factorize the denominator?
Yes.
Yes, we can write like this. So Laplace inverse of s squared divided s minus 1 squared, s minus 1, s plus 1. Am I right here? Which is given to be Laplace inverse of s squared divided s minus 1 all to the power 3 times s minus 1. And do partial fraction.
Doctor, it is s plus
Last one, yes, you are right. So here plus 1 and here plus 1. You are right. Okay. So this, it is plus here. And do partial fraction now for this. How to do partial fraction? It will be a over s minus 1 plus b over s minus 1 squared plus c over s minus 1 to the power 3 plus d over s plus 1, and find the value of those constants. Now let us discuss, can we use another methods? Can I write this fraction as a product between two fractions? Yes, I can do that, to use one of today's rules. But by the way, to be honest, using partial fraction for this fraction is the easiest method now for this problem. Here, to find the inverse of this fraction, the easiest one is the partial fraction. So please do partial fraction and send me your solution on WhatsApp. Do you have any question now? If no questions, let us speak about the final exam. The final exam must be comprehensive, okay? But I can discuss with you if you don't want me to include all the lectures. What do you think? In the previous section, one student asked me to exclude the graphical lecture, which we used the isocline and the slope field. So now, please, if you have any suggestion, or let us discuss this idea. What do you think? For me, I can deal with, yes, Islam.
Go ahead. Yes.
Yes, speak, Islam.
Okay, I was suggesting to exclude also the lecture of the spring and mass.
Okay, I understand. So first, so you want me to exclude the slope field and the isocline in the same lecture, isocline, and also you want me to exclude the lecture of Sebring, which I think it's lecture 15, and this one, I'm not sure about the number of this lecture, but this one is number 15. For me, I can listen to all of you. Do you want me to exclude other lectures?
Laplace, يا دكتور.
No, No, at all. I can't do that. And by the way, if any one of you asked me to exclude first lecture from Laplace transform, I can't do that because Laplace transform is serious. You need to understand all of them. But now, if I didn't include this lecture, no problem for me because you can solve other lectures, you can solve other problems. So I can do this, and I can do spring because it's an isolated lecture. And I think also one of your colleagues text me on WhatsApp. He need to exclude the problem of the phenomena. If you remember, we studied the population and the.
Yes, doctor, the linear.
Yes. هو ده
So what do you think?
Yes.
هو السبرينج مش مشكلة، بس هو اللي هي الفينومينا بتاع التمبريتشر والبريشن جروث ده اللي صعب. مش
Yeah, it's more difficult. And because you have at that time we have linear model and non-linear model. 2 lectures, I remember, 2 lectures. So if I exclude some lectures, so it will be the Sebring lecture and the phenomena here for first order differential equations and the slope and isocline. I'm going to text you on WhatsApp and tell you my decision that I'm going to not include some of those lectures, okay? But the others are very important and you need to study. But please wait me to text you on WhatsApp, okay?
دكتور هو الامتحان 8:30 برضه.
Yes, the final actually I can't do anything for the final as you know. The final
8:30 صعب قوي، الواحد بيمشي من البيت الساعة 7 عشان يعرف يوصل قبل الامتحان.
Actually, yes, I leave my home at 6:30, and I arrive to the university 7:30, and I will stay maybe more than half an hour, and no one to open my office. So I will stay walking. I can't do anything for the final, by the way. Because the time of the final exam before the university decide the time of the final before the semester. Okay. And by the way, it's last day, and after that you have a long day to play with your colleague after the exam. If you don't have more than one exam. Okay. So I can exclude those, but let me text you first. Then you can study the other lectures. Okay? Do you have any question now?
I have a question بس يا دكتور.
Yes.
هو السبرينج اللي هو springs هيتشال منها برضه اللي هو الدامت والundampt صح؟
Yes, both of them. Yes, those are in one lecture. So if I exclude them, both of them will be excluded. Okay? Now, last thing which I want to tell you, for those students from section 1, actually the students from section 2, most of them submitted their evaluation. So the university will share with me the evaluation. But the number of students of section 1 isn't enough. So if anyone of you from section 1 and didn't submit the evaluation, please do that today, because today is the last day. Okay, and thank you. Do you have any question now? We can meet at 1 o'clock if you need to discuss the worksheet together.
Thank you, doctor.
Welcome.
Okay, thank you.
دكتور هو لابلاس هيكون قد ايه من الفاينل؟ هيكون كام % يعني؟
Yes. I'm not sure, maybe 50 or more. 50% or more.
يعني يكون مثلا 3 أسئلة من 6 مثلا؟
Repeat.
3 أسئلة أو 4 أسئلة من 6؟
Just 1 minute. Here question and here question. 3 questions. 3 questions for Laplace transform and 1 question for tomorrow lecture. Not tomorrow. After tomorrow, which isn't Laplace. Okay. So the materials after exam 2 about 55 to 60% of the total of the final exam. Okay, the Laplace about 40. Okay.
تمام، شكرا دكتور.
Welcome. Other students, do you have any question?
Thank you.
Welcome.
Thank you,
David.
Doctor. Bye.
Welcome.
Thank
Bye
you.
bye. Bye bye, all of you.
Doctor, I have a question.
Yes, Khalid.
Yeah, I texted you regarding.
Actually, Khalid, I didn't understand. I didn't understand. What do you want to do?
Remember when we talked about if it's possible for us to take like midterm 3 and take the best of 2 and like that,
Yeah.
and you told me
Yeah,
that you'll ask the administration something like that.
Yeah, I remember. Now let me ask you, your total now is about what? Out of 50. So exam 1 and exam 2. Do you remember your grade?
Yeah, exam 2, I got 55 out of 104.
Yes. No, you can consider it about out of 100. So you get 55. So divide by 4, please. Divide by 4. So you will get by 4. So it will be maybe 13. Maybe 13 like this. I think 13. Am I right? 13.
Yeah, it's about 14%. Yeah, about 14%.
Yeah.
13.75.
Yeah, and exam 1?
No, exam 1 I got a very low grade. Got about remember 15 or 20 out of 100, something like that.
Yes. What about of your worksheet and your worksheets and your web assignment?
The worksheets, I submitted them all apart from 2 worksheets only. The web assign there's a specific period where there was a problem with the axis and like that, and I sent you after it.
Yes. I
So
remember.
I missed some.
No problem. Actually, because I can't do the look, in exam 2 we have 4 marks as bonus. 104. I'm not going to consider it as the total. No, the students will divide its mark by 4. Then I will consider out of 25, not out of 104. Okay, those are bonus. But I can't do the third midterm. But don't worry. I can help in the web assign, and I think for the worksheet also you missed the 2 worksheets. Am I right?
Yeah.
I can exclude also 2 worksheets at least. So you will take full mark for the worksheets and the full mark for the web assign, because I can help for the web assign if you didn't do some of them and you text me on WhatsApp that you have a problem. So I can help also for the web assign. But for third midterm, I think it's very difficult to do that. Now, I want to ask you, what about your final? Did you start preparing for the final?
Yeah, I started studying for it, but I'm like the material is very comprehensive, so I'm
yes,
a bit worried.
you are right. But so now I'm going to exclude all those lectures that I told you during the lecture.
Okay.
So maybe it will be easier now. And I advise you to study the Laplace transform very hard to get full mark of the questions of Laplace transform. Okay. And I noticed from your paper of exam 2 that you did right. But I think you didn't solve the first problem of the spring. Am I right?
Yeah, because I thought that this wasn't included because when I solved, someone sent that this is not included in the midterm, and then I didn't study this part, so I was shocked.
Yeah.
Also, I had a problem with the time. I was a bit slow, but I think the questions I answered were correct.
Yes, you are. So you lost. Look, you lost 30 marks, and you get your mistakes only 15 marks. 30 mark you didn't study of them. So I think your final will be good. Okay.
Okay.
And don't study the spring at all.
Okay.
Okay. Don't worry. I hope that the course will be